How's it going, everybody? In our next video, we're going to be wrapping up the DMVPN section with our last DMVPN topic, which is going to be VRF aware DMVPN. Now, there's multiple ways that we can implement this, but really at the end of the day, the way that this all ties back is being able to separate the routing traffic from one type of connection from another. So for those of you that are not familiar with what a VRF or a virtual routing and forwarding table is, it's essentially just a user-created routing table on a router or a switch that supports VRFs that allows you to begin to separate traffic. Now, we've already got VRFs configured on CSR 8 to do routing just to demonstrate it as if we were, instead of having multiple additional routers, I just created a VRF on a router so we could, multiplex it to be used in multiple different places. So that's basically how that's coming into play. So we have 4 VRFs, S4, S5, S6, and S11. Well, you can also use VRFs within IPsec, but it's technically it's not really an IPsec specific technology. It's more of a phase 1 type of operation. So basically what ends up happening is there are scenarios, and there are more routing specific scenarios, and we'll talk about that briefly as how they come together so that you guys can see exactly what it is I'm talking about. So oftentimes you want to be able to, if you put everything in the global routing table, so like you have a static route pointing towards your internet connection in the global routing table, plus you have all your LAN facing interfaces in the global routing table, then you also put your tunnels that are traversing over the internet or your MPLS or whatever your WAN connectivity transport mechanism is. All that stuff goes in the global routing table. That means everything gets commingled. So you potentially could have the capability where you have to deal with doing redistribution and do route filtering and preventing routing loops and route feedback. It makes it messy when you start commingling everything into a single routing table. Where if you deal with a VRF, you're actually able to start to segment that based off of a different routing table itself. So we have the global routing table, also known as the default VRF. Well, that's the global routing table. If you are on, say, CSR3, and we do a show IP route, this, ladies and gentlemen, is the global routing table. I mean, there's really nothing that fancy about it, really. The cool thing about it is, when we look at how this all comes together, when you create a VRF, you can put it on any interface you want. So what's often going to end up happening is you're going to want to separate your control or your underlay from your overlay. Let's just redraw this again since it got erased. When we talk about the underlay versus the overlay, we'll talk about the underlay first, which is the yellow-green. So we have the underlay connectivity, which is going to be all of the physical connectivity that plugs into the device, right? So we'll do all that, and this is going to be basically how all this stuff comes together. So you have all this connectivity that's connecting all these devices together. The physical wires that are physically getting devices to talk to each other. Then we have the control plane, or the overlay. The overlay is going to be a different aspect of this, and I'm going to grab a couple of ellipses. I'm going to draw because currently we have two clouds. So we're going to have one cloud here and then another cloud here. Well, what's going to end up happening is we're going to have a scenario where we're going to have this guy connecting to this guy, and then this guy connects to this guy, then this guy connects to this guy, and then this guy connects to this guy. Right, we have all that. Then we have CSR3 connects to that hub or that cloud, then this guy connects to this cloud, this guy connects to this cloud, and this guy connects to this cloud. The drawback you run into is that everybody has reachability to everything. So if you want to eliminate any potential routing feedback loops or any type of issues that you could run into with a routing table, I'm not saying it gets rid of all of them, but it makes it easier to separate traffic, one type of traffic from another. So normally what's going to end up happening is you'll get into a scenario where you're going to take this interface right here. So your gig 1 interface on CSR3, your Gig1 interface on CSR4, and you're going to place those interfaces into a VRF. That VRF is going to be specific to whatever transport it connects to, like whether it's MPLS or it's internet. I've seen this more commonly deployed on the internet side of the house, because normally it's just going to be a default route pointing to the internet. Simple as that. Really nothing to it. So the idea is I can go and create a VRF called iNet, for example, and place it on the outside interface. And that's going to allow me to separate my underlay connectivity from my overlay connectivity. So that means that I would place my underlay connectivity, my static route pointing out towards CSR1 to get me to any of the other devices on the internet, in my simulated internet here, to be able to be separated from my EIGRP tunnels, my EIGRP land-facing routing, all that type of stuff. Where my tunnel interfaces are in the global table, right? And what ends up happening is I actually will tie the tunnel configuration. The tunnel itself will still be in the global routing table. But there's going to be this special command called tunnel VRF and then whatever the name of the VRF is. So iNet, for example. What you're going to be doing is you're going to be telling the tunnel that its source interface is going to be inside of the VRF. Then you're going to map the tunnel to the VRF by typing in the VRF name. So technically it's going to be a double mapping where you're going to say the tunnel source will be Gig1 on all the routers, but Gig1 will actually be inside of a VRF called iNet, and then you're going to tell the tunnel to use the tunnel VRF of iNet. This gives it kind of like a mapping, if you will, to know where to recur. It's not in the global routing table, it's going to be inside the VRF. And then once this is done, you can go ahead and begin trying to bring up your DMVPN tunnels. There's a couple of VRF specific commands that we haven't talked about yet that come into play when we get into dealing with VRFs, which is going to be the ISACamp keyring. The keyring is needed because now it ties to a VRF. When we get into IKEv2 with FlexVPN and just IKEv2 in general, the keyring is going to become more and more common because it's usually tied to using pre-shared key authentication between a bunch of IKEv2 nodes. We'll talk about that more when we get into IKEv2. But the keyring is going to be used to tie to the VRF. Once the VRF has been created and then mapped to all the appropriate interfaces, then you have to go and do the keyring config so that when you are doing the keyring that you can pass the pre-shared key information and do all the phase 1 setup inside of the VRF so that it knows to map it to the tunnel interface, which is in the global routing table. At that point, you've then separated your internet connectivity from your overlay connectivity, or your underlay from your overlay. They're in two separate routing tables. By doing this, you're actually giving yourself more scalability, because then your underlay is completely routing separated from your overlay. So any things that you have going in the overlay going on aren't going to be affecting the underlay. However, the underlay can still affect the overlay. If you lose a circuit or you lose connectivity to a particular destination, that can still cause problems to the overlay. If a circuit goes down, that still can affect the overlay. So it doesn't get rid of those problems. What it does get rid of is any issues you might have in terms of dealing with a messy routing table. It does give you a lot of scalability there. So what we're going to go do is we're going to go through and we're going to configure CSR3 and CSR4 to do both a hub and spoke configuration. So we're going to see it on both sides so we can see exactly how this comes together. Configuration wise, it's the exact same config on both ends. But I just want to show you how it works on both ends just so you have the visibility and the understanding. So we'll go through and we'll get that squared away and configured. It's actually relatively simple to do. It's just something you definitely need to know how to do. So I'm actually going to go up here to interface tunnel 100. I'm going to shut down the connection. That's going to take my connections down to 4, 5, and 6. And then I'm also going to go down to interface Gig1. I'm going to shut the port down, and that's going to get rid of the default route. So now I need to go and I need to create a VRF. I'm going to call it VRF definition is going to be iNet. Now the reason why I'm choosing the definition and not IPVRF is because of the fact that we'll need to cover IPv6 at some point in the future. I'm going to type in the address family is going to be IPv4 unicast and IPv6 unicast to allow those two address families to be able to send and receive traffic. Now, the moment you apply a VRF to an interface, it's going to go ahead and remove the existing IP addressing information and then place it into the new VRF, or the new routing table. So do show run interface gig1. We're going to go underneath interface gig1 and we're going to type in VRF forwarding is going to be INET. Now it says that it removed the interface config. No big deal. We just go ahead and reapply that, just like this. Pretty simple stuff. Now what we'll have to do is type in no shut. We'll bring the interface back online. But if we look at the do show IP route VRF INET, you're going to see that it's all by itself, right? Give that a couple seconds for it to come online and be squared away. So now the interface is there. But you'll notice that there is no default route. I can't talk to anything. So if we do show run pipe include IP route, you're going to see that we have a default route in the routing table pointing towards CSR1. But if we look in the do show IP route, the global routing table, we can see we have a lot going on here. What I need to go do is I actually need to go and configure a gateway of last resort inside the VRF. So I need to type in no and pull out this default route and type in IP route VRF INET 0.0.0.0.0.0.0.31.0.0.1. Okay, now if I hit the do show IP route VRF INET, now we're going to have a default route in the routing table. Now what I have to go do is for all of these configuration commands that are done in the global table for all the keys, I actually have to create a new one. So I had to type in the command crypto isocamp and then keyring, or is it crypto keyring? Crypto keyring. The name of it is going to be VRF aware VPN, and I'm going to type in what VRF this particular keyring ties to, which is going to be VRF INET, and then I hit the enter key. I'm going to come underneath here, and I'm going to type in the pre-shared key is going to be address of, I'm going to type in 0.0.0.0, and I'm going to type in key of Cisco. I'm just going to say, you know what, I don't care who is peering with me, I'm just going to let them connect in. But you'll have higher level protocols handling things like that. You'll have NHRP authentication, you'll have EIGRP or BGP authentication, things like that. You'll have IPsec. You're going to have multiple layers of configuration in place to prevent this from anybody trying to brute force this guy. Now that we've got that configured, we can exit out, and then we need to go underneath the interface. So do show run interface tunnel 100. Go interface tunnel 100, and now what we need to do is we need to type in the tunnel, and then down here at the bottom we have VRF, and then the name of the VRF is going to be INET. The reason why we have to do that is because we need to tell the tunnel that the VRF that it needs to use to recurse to the tunnel source is inside of the VRF of INET. Do show IP route VRF INET, and we have gig1 sitting in the INET VRF and is good to go. So now we're going to come in here and type in no shut, and by doing that the tunnel is going to come back online. Our tunnel is going to come online and we start forming our EIGRP adjacencies again. So after a short period of time we should be able to get all of our tunnels back up, which we do, and now we have configured VRF aware VPN. Now the south side of that is going to be configuring CSR4, which is the exact same process. It's just we wanted to see what it would look like in the hub. Now we're going to go configure it on the spoke. Same concept applies. So the cool thing about this is if we do show IP route, what you won't see is a gateway of last resort. You won't see a default route. And this, when I've commonly set this up, I've usually done it to separate BGP. So BGP from the underlay and BGP from the overlay. You can use the same autonomous system number for both, which you have to. But when you do BGP in the VRF, you're using that to connect to the provider, but then you're using BGP over the top through the overlay, and that gives you much more scalability. So it's up to you and how you want to go about doing that, but that's basically how I go about doing it. So what I'm going to go ahead and do is I'm going to go set up CSR4 to do the exact same thing, and we're going to see exactly how this comes into play. So I'm going to go ahead and create the VRF. So VRF definition of INET, address family IP4 unicast and IPv6. We're going to go ahead and put do show run interface gig1 into, we're going to take a look at that. And then we're going to type interface tunnel 100, shut it down, and then interface tunnel 200 and shut it down. We're then going to go jump back over to interface gig1. We're going to say VRF forwarding is going to be INET. We're going to reapply the IP addressing just so that it's there. Get it configured. And then we're going to jump out of global config, do show run pipe include IP route. We're going to go ahead and yank that static default route that's in the global table out. Oops, no, and paste that in. And type an IP route VRF INET 0.0.0.0, 0.0.0.0, 41.0.0.1. And then we're going to go to the crypto keyring of VRF aware VPN and the VRF of INET, and then type in the pre-shared key is going to be address of all zeros, and the key will be Cisco. Exit out, then go underneath interface tunnel 100, VRF or tunnel VRF is going to be INET, no shut. Give that a second to come online, and then we're going to type in interface tunnel 200, tunnel VRF INET, and then no shut. There we go. So that, ladies and gentlemen, is how you do all this. Fairly straightforward. So if we do show IP route, we're going to see everything in the global table. Everything looks right. Everything is doing its job. And that's really what you want to see. You want to make sure that the VRFs are in the right place. Do show IP route VRF INET. We have do show IP route VRF INET. We can see we have a default route in the routing table for all that. And if we do show run interface tunnel 100, we have the tunnel VRF INET. Remember, the tunnel itself is not inside of the VRF. The tunnel is referencing the VRF of INET, which allows the tunnel itself to stay in the global routing table, but reference its underlay reachability attached to gig 1 inside of the VRF of INET so that it can reach out to the internet and do all of its things. So that's where this really comes into play. That is basically how this works. So now what we get to go do is do a little bit of testing. Let's do show IP route VRF S4. We have a bunch of routes in the routing table. So now I get to go here and do a trace route VRF S4 to 192.168.60.8, sourcing from loopback 192.168.40 numerically, and hit the enter key. So I go through router 3 in order to get that. I hit the up arrow again, and guess what? Now that I've got that connection between we started in 60, but we're going to 40. So if we jump over here to CSR 6, oops. So we're going to go to here and do a show crypto ISA. We have a connection going to router 4, show DMVPN. We have an active connection going to router 4 from 6. And we do a show IP route and hit the enter key. We can see that that's going over to 40. Now if we look in the global routing table CSR 4, show IP route, we're going to see the NHRP override here, and we're going to so the next hop override, and then we're also going to see the NHRP mapping inside the global routing table. None of this is inside the VRF. So this gives us a lot of scalability. So you can peel away your overlay routing from your underlay routing as long as you have it operational. That's the key factor here. So that's pretty much what I wanted to cover in this video. There are other options and stuff like that, like VRF Aware, DMVPN, and things like that. We'll be covering those at some point in the future. We just want to make sure that we understood this aspect of it first. So, because this is kind of a little bit more of an advanced topic, especially if you're not familiar with VRFs. It is pretty straightforward stuff, but it's important for you definitely to understand. So, until next time, guys, thanks so much for stopping by and hanging out with me. And until next time, take it easy.